if you ever see 4i and 4j and you're doing two different loops in an easy problem, you might be doing something wrong. Just throwing that out there. Hey everyone, Stephen here from Be a Python Dev. We're on some Leetcode. We are in the Explore section, and we're going to continue the previous. All right, so as I was saying before, it looks like they got these monthly coding challenges. They're on day 15 of the June guy. I want to finish all this so I can start going through these. These will probably be harder problems. It'll take me a little while to work through. And it looks like there was some May ones too. So maybe I'll just work through all the May ones, just kind of catch up and see what this is. Hopefully it'll be beneficial if I talk through them with y'all, or slightly entertaining. I don't know if you guys have been keeping up with these or not. I'm sure the problems are still good to work through either way. So if you're interested in coding problems and working through them with someone else, go ahead and subscribe to me because I'll be doing this pretty often. Hopefully I can get into a routine of doing this daily when I have time. Sometimes that doesn't always happen. At least twice a week though, I'll shoot for sure. Back to easy collection, top interview questions. We're still on the arrays. I actually finish these regularly, but we'll just do them on camera because why not? Might be fun. This will be the two-sum problem. Given an array of integers, return indices of the two numbers such they add up to a specific target. You may assume that each input would have exactly one solution, and you may not use the same element twice. I think when I originally created this, I did it in two passes. One to populate a set, and then two to go through the array again and then look at values of the set. But I think I can actually do that in one pass now that I'm kind of looking at it again. So that will be cool to optimize and improve on my previous solution I did a long time ago. But again, the input is a target and a nums list. They said for your assumptions, you can assume that there's always going to be one solution. Normally, you might have to improvise and store a list of tuples or something that might have multiple indices, or you kind of want to clarify with someone that you're working through the problem, like how many solutions could there be? Is there many solutions? Is there only one solution? Is there a chance there's zero solutions? Do we have to deal with negative numbers? All that fun stuff. You might actually have to deal with negative numbers in this. Yeah, I don't think negative numbers would change the problem per se. Because if you saw a -2, you would need an 11, and you'd kind of determine that math's the same way. So anyways, we're going to need to iterate through this list, and we're also going to need a set of tuples. The tuples will correspond with the value and the indice of which we saw that value. Since one of the requirements of this is to return indices as a list. So we'll actually track that right here. We don't need to. We can just form that in response because Python will let us do that easily. For num in, actually we want to enumerate this. You can also use range. Range is a little more convenient. For I in range, length of nums. What is this thing? This is going to be our values set. Just call it that, and then we'll do this. I always forget how sets are created in Python if you're not using the actual object identifier. I don't know if, I can't remember if it's, I don't think it's parentheses because those are tuples. It's not that because that's a dictionary, but maybe a dictionary is just a set without values and it's just keys. That's not important here. We can look up that later anyways. All right, so what we're gonna do here is we're gonna go through each index of this length. We're gonna see if there is its corresponding value. What do we want to call that? It's complement. We'll just call it the complement. To find the complement, we need the target minus the, that's not actually going to work. Yeah, this is going to need to be a dictionary. The dictionary, the value is going to be the key. The index is going to be the value. The values dictionary, the key, and the value, and I said that very complicated. Anyways, yeah, we'll call it complements dictionary, so it's a little less confusing. So the complement is the target minus the value in the array. So actually, let's just save that here. Because we're going to need to store it in a couple places. So the complement is the target minus the val. If complement in complement dictionary, return. So the complement index is always going to be smaller than the index we're currently on, because that's just how our algorithm is working, because we are populating as we traverse the original input array. So since we know the smaller value is always going to be the front one, we can do this. Complement dictionary and then the complement value, and then value. So according to the problem, since we can always assume there is going to be an exam or an actual answer, I think that's all we need. And if it's not there, we'll just populate the complement dictionary with the value that we just looked at, and this equals the index that we're looking at. So this is a little interesting in that the return isn't at the bottom of the function, but the return doesn't always need to be at the bottom of the function, so long as we will always execute a return statement. If not, Python will just return none by default. In this case, it should always return a list based on the requirements that were given to us. And since we can go off of that as our actual assumption, I think that's all we need to do. So this isn't even a full pass, because it's going to return early before actually hitting the last element in the array, unless the last element is the actual complement. So this isn't even always ON. It might be less than ON, but for the sake of the big O discussion, you just assume it's ON. Best case scenario, it's O2, because it might be 1 and 2 in the array, and then it'd be constant time. But again, you can talk about that. You can throw it out as a hypothetical situation, but best case O2, worst case ON. Let's run this code. I think I didn't. Oh, I did hit a runtime error. Oh, why did I do that? This guy should be this. All right, my answer 07, 01. Am I returning the index? I don't think I'm returning the index. I think I'm returning the value. So that was done with me. All right, run code. 01, 01, show diff, blah, blah, don't need to do that. Normally, I'd like to try to run some custom test cases and try to think through edge cases, but I think this is kind of self-explanatory enough that we don't really need to go through that. So we'll just submit this as it is. All right, submission result accepted. I'm assuming if we go into more details that it should be a good runtime. It should be, yeah. We'll just go ahead and do that, and we'll talk about it. All right, so accepted solution, runtime distribution. Your runtime beats 80% of Python submissions. That's exactly what I assumed would happen. It's surprising to me that there's a large clump of answers here at the 1000 milliseconds runtime. So what do these look like? For I in range, value equals target minus nums. Yep, that's what we did. If value and nums nums.index value is not equal to I, return I plus nums index value. It looks very Pythonic, and apparently that's doing enough Python magic that has associated costs with it that it's not optimal. So yeah, whatever this guy's doing, don't do that. If value and nums Oh, okay, because this if value and nums, this makes it actually be n squared. N squared is, you don't want to do n squared. That's why this is so bad. You always want to use sets and dictionaries if possible, compared to doing in list, because that just blows up your runtimes. I assume all of these are probably doing the n squared solution. Oh, I want to drag it. There we go. If adder and nums, yeah, all these are probably going to be doing that. If difference in nums, index plus 1. For index num, if length nums equals 2, return. Yeah, if you have the optimal case, you don't even need to do this. This is just silly. Okay, anyways, and then space distribution, 47.92% of Python submissions. How can you do this in less space? It doesn't look like there's a big difference in the space solutions here. Maybe that's because almost all of the answers are using constant arrays. What is this? L equals empty list, k equals 1, s equals false, for I in range, for j in range, k length nums. So this is a brute force n squared runtime, where he's seeing if these two added up equal the target, and then he's populating the return list. L equals true, break. Yeah, this one's not good. The readability on this, I don't recommend this approach. If you ever see 4i and 4j and you're doing two different loops in an easy problem, you might be doing something wrong. Just throwing that out there. All right, anyways, looks like we are at the 10-minute mark, a little bit more. Might have to edit out where my fiance came in and interrupted me, but I hope you guys like these explanations and kind of these fun little easy problems, and then talking about the different runtime and memory distributions at the end. Let me know if you guys are feeling that. If not, I can just stick with the solutions and go with that. Thanks. Have a good day. Bye.